Today we're going to try number 26, remove duplicates from sorted array. It says solved. I tried it probably like years ago in Python. There's no way I'm going to remember it. Given an integer array nums sorted in non-decreasing order, remove the duplicates in place such that each unique element appears only once. The relative order of the elements should be kept the same. Consider the number of unique elements in nums to be k. After removing duplicates, return the number of unique elements k. The first k elements of num should contain the unique numbers in sorted order. The remaining elements beyond index k through 1 can be ignored, or k minus 1 can be ignored. Custom judge. The judge will test your solution with the following code. Examples: if we have this short nums, your function should return k equals 2, the first two elements of nums being 1 and 2 respectively. It does not matter what you leave beyond the k, hence they are underscores. This one we have 0, 0, 1, 1, 1, 2, 2, 3, 3, 4. We just remove the duplicates. Your function should return k with the first 5 elements. Does not matter what you leave beyond the returned k. Now looking at the approach, my initial instinct is just go through the nums array and put them in a hash set, because you can only, wondering if that's like not space efficient or something. Your function should return k, int k equals 0, removing duplicates. Finally, what we're going to return are k and nums. So in between these two lines, we have to do some cleaning. The way we are going to remove the duplicates, and they're also saying that remove the duplicates in place. The thing is, it's that there is still something in there. We can just say null. And then I think we could use a counter. Do we need that? So what is k? I don't think we have to count how many duplicates we're removing. So a flaw that I'm seeing right now is that this is gonna say null to even the very first time the value gets added, because it's going to contain it. I don't know how to like null it. So arrays are immutable, so you can't remove it. I can't assign null value to it. So I'm like wondering, what do you want me to do here? I don't know how to assign underscore to it. So let me at least comment it out. Reviewing with Claude. So correct idea of tracking the unique elements with the k. Iterating through array is the right starting point. Understanding that duplicates need to be moved somehow. Misunderstanding the problem's intent. It doesn't ask you to delete elements. Overwrite the front of the array with unique values in place and return the k. Nums.contain is always true. That's always yes. You need to track what you've already placed at the front. Approach is using a 2-pointer. If it's edge case, I did not even address that. Okay, so first element is always going to be 1, unique. And then they loop through it. Duplicates are always adjacent. If the first index's value is not equal to a, so I get that the duplicates are always adjacent. So if the value in the index I does not equal to k minus 1, the problem only wants you to return k. The array is modified in place. The caller handles the rest. When you are stuck on how do I remove it, that's usually a signal the approach needs rethinking, not a syntax fix. Just need to lean into the constraints of the problem more. Good effort. So my initial instinct of hash set definitely works, but did not comply with the constraints that were given. And it seems that the keyword from the problem was the sorted array. Because if we were to use hash set, we were using extra memory. While it works, that was not the learning point for this problem. Learning point for this problem was realize that duplicates will be adjacent and come up with this particular logic, this line, place them in the front instead of like kind of moving down. It's always the back elements that are vacant, not, for example, it's not going to be like 0 empty, 1 empty. It's always going to be pushed forward. I guess I didn't quite catch that, like grasp that properly. So today we tried number 26. Main learning points for me. Number one, I should try to understand the problem better. I didn't quite catch their intention of moving the unique elements forward. And when they displayed the rest like this, I thought that we were supposed to do something about it in order to empty out those slots. But according to Claude, just ignore them. They're still going to contain the old values. We're just not going to care about it. There was slight misunderstanding as to like what I was trying to get out of it. Even like the return statement, I was thinking that we have to return the count and the array. Simple, but you can't return more than one value. The fact that they wrote it out like this, for me, was a little bit misleading. I'm like, why or how? Like, unless you're asking me to like print console.writeLine k and then the nums, maybe that was the intent. But I guess like that's relatively small thing. The main logic part I didn't quite capture was this part. If the duplicates are adjacent, the way you compare it is by doing nums I, comparing it to nums of k minus 1, and k gets incremented. Yeah, this part, I can't say that I feel natural looking at it. Like, it makes sense, but it just doesn't feel right writing it like this. So I think I'll have to chew on it a little longer. Curious how I wrote it back in the day. This seems simpler, but it makes more sense, right? Like, because they're adjacent, you just delete following indices values if they happen to share the same value. It has performance issues. The one real problem is that deleting is expensive. This is O of n squared. That is pretty bad. I feel like whenever it's O of n squared, those are like the most intuitive problem solving. I wish I could, turn a switch on to change my thinking from O of n squared to maybe log n or something.